All right, so our lesson for today is all about estimation. What is estimation? What is estimating? In your own words, what does it make you think? I know a lot of kids tend to say rounding. When you estimate, you're rounding numbers. Get rid of that little box. No, can't do it. There we go. So, rounding, yes. And estimation is more specific in that it is an answer. It is not an exact answer. It is an answer that is almost the exact answer. It's close, but it's not exact. So, why do you think estimating is important? Well, I think estimating is important. I actually use it as an adult. It's something that I use almost on a daily basis. And it's something that is helpful in math. So, used in math and pretty much on a daily basis, maybe without even realizing it. When do I use it, you might ask? When in the world, Mrs. Leith, are you using estimation? When is this going to be helpful? Well, if you think about in math, estimation is going to be helpful when you are wanting to know, is this a reasonable answer? We want to make sure whenever we solve a problem that the answer that we get is reasonable. Sometimes when we make little mistakes, our answers can be outlandish. And we need to be able to recognize something like that when it happens. And so you always are asking yourself, as you're solving problems, is this a reasonable answer? Now, okay, so going on to that daily basis thing. Um, on a daily basis, can't see my eye, there it is. On a daily basis, I use math estimation when I'm shopping. I estimate the amount of money that I'm spending. When I am figuring out bills, and you might not do this right now, but you will be doing it in the future. Trust me, everybody shops. You have to shop for food, clothes, stuff you want, and estimating helps while I'm walking through the grocery store. I pick up some milk, okay, $2. Is it really $2? No. Is it about $2? Yes. And so I keep an estimation in my head to help me figure out if I'm spending too much money or if I have enough money to buy something that I don't really need, but maybe I kind of want it. So, estimation is something that is actually used on a daily basis, and people just don't even realize it. So here we are in math. Estimating is what we're practicing today. Up here, I have a box. To estimate means you're rounding the number. First, here's a little tip. Underline the digit to be rounded. Then look at the digit to the right of the place being rounded. So if I'm looking at 8 and 7 tenths, 8 is what I'm going to round. That means I'm going to look up here to the right at the 7. Now the rest of this is going along with the 7. Is the 7 4 or less? No. Is the 7 5 or more? Yes. That means the underlying digit increases by 1. So since 7 is greater than 5, my 8 becomes a 9. And if you think about the number 8 and 7 tenths, let's go down here. 8 and 7 tenths. If I were to put it on a number line, we'd have 8. And if we're counting by tenths, we'd say 8 and 1 tenth, 8 and 2 tenths, and then 8 and 7 tenths would be somewhere over here, and then 9 would be somewhere over here. And 8 and 7 tenths is closer to 9. It's all the way back to 8. 8 and 7 tenths is closer to 9. That's why it rounds up to 9. All right, let's look at 4 and 2 tenths. I'm going to round to the nearest whole number. And so 4 and 2/10. I'm looking at the 2 to determine what happens to the 4. It is 4 or less, so that means it stays the same. So I'm going to multiply. In order to estimate this, I'm going to multiply 9 times 4. And that's easy to do. 9 times 4 is 36. So my estimation for 8 and 7/10 times 4 and 2/10 is 36. Is 8 and 7/10 times 4 and 2/10 exactly 36? No. I could get my calculator out right now, just for sake of time, and find that 8 and 7/10 times 4 and 2/10 is actually equal to 36 and 54/100. 36 is really close to 36 and 54/100. It's a little less than 36 and 54/100. Let's try another one. Estimate 42 and 6/10 times 37 and 2/10. In this case, I'm just going to that first digit, which is the 4. It's in the tens place of our whole number, and I'm going to look next door to figure out, is the 2 going to keep the 4 the same or push it forward? Well, 2 is going to make the 4 stay the same. Now I forgot to mention, after rounding, all places after the underlined digit have a value of 0. So that means after the 4, the 2 becomes a 0. I could also put a decimal in a 0 here, but when we write the number 40, we don't put a decimal in a 0. We just write 40, and it's okay if you write it that way as well. For 37 and 2/10, we're just going straight to that first digit, which is a 3. And we're looking at the 7, and what's going to happen to the 3? Is it going to stay the same, or is it going to increase to 4? Right, it's going to increase to 4. So that means 37 and 2/10. If this 3 increases to 4, everything else becomes a 0. Our digit, or our number that we're working with, is 40. So 40 times 40. Now, some of you might see this problem, 40 times 40, and think, whoa, I can't solve that. But let me remind you of when we're working with multiplication, and there's a bunch of zeros on the ends of numbers. The 0, we got one here and one here. We can just look at the whole number, 4 and 4. Let me get rid of that box. There we go. And we can multiply, extend the screen. We can multiply 4 times 4, and I know that that is 16. Well, I have to go back to my problem. How many zeros are in the problem? 2. That means I add 2 zeros. 4 times 4 is 16, but 40 times 40 is 1,600. So an estimation for 42 and 6/10 times 37 and 2/10, it's about 1,600. All right, let me get my calculator out and I'll tell you the exact answer. See how close we were. 42 and 6/10 times 37 and 2/10 is actually equal to 1,000. Let me write this down. 1,584 and 72 hundredths. So it's a little above the answer, but it's almost the same. They're super close to each other, and that's what an estimation is. So let's think about, why is 1,600 more than the actual exact answer? And why is 36 less than, what was that answer again? I forgot to write it down. Let me check. 8 and 7/10 times 4 and 2/10, it is 36 and 54 hundredths. So why is it that 36 is less than 36 and 54 hundredths? But here we got 1,600, which is more than 1,584 and 72 hundredths. Take a minute to think about, why is it that this one is less and this one is more? Well, let's think about what we did up here. 8 and 7/10 became 9. It actually became more. this increased. The 8 7/10 increased to a 9. I'll put a positive sign since it's increased. 4 2/10, this one decreased because 4 is actually less. If you think about money, $4 is less than $4.20. So here our number increased and we multiplied by a number that decreased. And our answer is super close, but it's smaller than the exact answer. If we go down here, 42 6/10. Well, this number decreased. Decreased. So this number decreased. And 37 2/10, this number increased. So that's pretty much the same. We had an increase and a decrease. We had a decrease and an increase. So why is it that this number is smaller than the exact answer and this number is larger than the exact answer? You know what I think it is? I think it's because if we think about 37 2/10, that's kind of far away from 40. And we made it a 40. And 4 2/10, that's pretty close to 4. So these numbers are actually much closer to our original answer numbers than the numbers down here that we rounded to. What number could we have rounded to and got a more closer answer to the exact 1,584 72 hundredths? Maybe instead of rounding to the largest number or the largest place value in each number, if we were to round to the nearest whole number, so then our problem would have turned into 43, because the 6 would make the 2 turn into a 3, times 37, which is not as easy to do in your head because there are no zeros. But let me tell you, for sake of time, what the answer would be. 43 times 37. Oh my goodness, look at this. I got 1,591. Look how close that is to 1,584 72 hundredths. I think what I'm getting here is that the closer your numbers are in your estimation, the closer your answer, your estimation will be to the exact number. So I think that's what we're getting at here. Let's try some of these on our own. Before you try some, I want to point out this funky symbol up here. It kind of looks like an equal sign, but it's got some waves in it, right? That's because that sign actually means almost. Oh boy, let me try that again. Almost. Oh yeah, it's not letting me. Try that. Let me just get rid of that. Sorry, my pen is not cooperating with me today. One more time. That symbol means almost. So when I see that symbol in a problem, I know they don't want me to find the exact answer. They want me to estimate. So this symbol, estimate your answer. Round and find an estimate. So I want you to pause it here and think about how you would round these numbers and the estimation that you would get for each one. Don't make it complicated like I did the first time, okay? I just wanted to show you that the closer your estimation is to the actual number, the closer your answer will be to the exact answer. Go ahead and round to the largest place in each number. So in 5 8/10, round to 5. In 13 92 hundredths, round to that 1, the first digit, the tens place, okay? All right, pause it, try them out, estimate, see what you get. All right, I'm going to assume you went ahead and paused it, and now you're back with me to see if you get the same answer as me. So if I'm going to estimate, remember I'm going to think about the 5, and I'm looking at the 8 to determine what happens to the 5. Well, the 8 is a large number, so it turns the 5 into a 6. And the 4 I don't need to do anything with the 4 because it's just a plain old 4 and I can't change it. I'm just going to leave it alone. So what is 6 times 4? 24. So our estimation for 5 8/10 times 4 is going to be 24. Let's see what the exact answer is, because now I'm just curious. 5 8/10 times 4 is 23 2/10. Super close. Very close estimation. All right, let's look at the next one. 13 9200 times 2 7/10. Remember, just look at the 1. What's going to happen to that number? It's going to stay the same. Now, this time I have to put a 0. You have to put a 0 until you get to the decimal. Once you get to the decimal, you can stop. I didn't have to put a 0 here because the 6, then it would have been a decimal. And I don't have to put zeros, and I don't have to put my decimal. So this 13 92 hundredths, I'm going to round it to 10 times 2 7/10. Let's see, the 2, the 7 makes it a 3. And I don't have to put any zeros because the decimal is right there. So what is 10 times 3? That's 30. So my estimation for 13 92 hundredths times 2 7/10 is 30. Now I'm predicting that my number, the actual answer, the exact answer, is going to be a lot larger. Why do you think I'm predicting the actual answer to 13 92 hundredths times 2 7/10 is much larger than 30? If you're thinking because that 10 is kind of far away from 13, you're right. I think that's why. The actual answer is 37 584 thousandths. 37 is not very close to 30. So if I would have estimated to 14 instead of 10, I would have gotten a closer answer. But I'm not worried about that. I just want you to show me that you can estimate. You know what? I don't care which digit you estimate to. Or round to. I just want to see that you can estimate and you understand what it means. Okay? So 94 89 hundredths times 3 11 hundredths is about what? If I look at this 9, the 4 leaves it alone. So 9 stays the same, but I need a 0 because I need to put a 0 where the 4 should be, and then I get to my decimal. Times, let's see, 3 is going to stay the same, and I don't need to put a 0 because I get right to my decimal after my 3. Now remember, just think about 9 times 3. What's 9 times 3? 27. How many zeros are in the problem? 1. So 90 times 3 is 270. Do you think 270 is going to be more or less than the actual answer? I think it's going to be less because 90 is less than 94. All right, the actual answer, oh goodness, is a lot of digits. 295 and 1,079 10,000ths. I think that's how you would say that. Yep. Ooh. So yeah, if you think about it, 270 is a lot less than 295. And that is because we rounded this number all the way down to 90. And that's okay because estimation, we can do that. All right, let's look at some word problems here. Something I want to point out with word problems is, let's read it. The record for the greatest distance traveled on skateboard in 24 hours was set in a recent year by James Peters. He traveled about 7 6/10 miles per hour. At that speed, about how many miles would he travel in 24 hours? You may have noticed I emphasized a couple words here. I emphasized about each time because about is a key word that shows you that they want you to estimate. They don't want you to find the exact answer. They want you to find an answer close to the exact answer. So we are going to round. And the numbers we're working with here, let's think about what is this problem even asking us to do, right? The record for the greatest distance traveled on skateboard in 24 hours was set in a recent year by James Peters. he traveled about 7 6/10 miles per hour. At that speed, about how many miles would he travel in 24 hours? Well, if I think about this, he traveled 7 6/10 miles per hour. Per hour, that means in 1 hour he traveled about 7 6/10 miles. And they want to know how many miles would he travel in 24 hours. So if he traveled 7 6/10 in an hour, how many would he travel in 24 hours? Well, I guess I could add 7 6/10 24 times. Seems a little repetitive. So I think what I'm going to do is estimate 7 6/10 times 24. So let's think about this. We need to round. 7 6/10 is going to round up to 8. And 24 is going to stay the same. Or you know what we could do is we could round it to 20. But I'm going to leave it as 24 just because I think it will be more accurate. I'm going to come over here and do a little work. 24 times 8. So that's 30. Oh, that's 32. 16. That's 19. So my estimation is about 192 miles in 24 hours. Hold on, let's think about this for a minute. Can you imagine skateboarding 192 miles in 24 hours? That's a lot of miles. That's a lot of dedication to skateboarding. 7 6/10 miles per hour. That's a pretty fast pace. I'm a runner, and there's no way I could run that fast. Maybe you guys could because you're younger and stronger. I'm old. I can't do that. All right, so is your estimation higher or lower than what the actual answer will be? Well, let's think about that. What do you think? We estimated 192 miles in 24 hours. Is the actual answer going to be higher than that or lower than that? So what we have to look at is the numbers that we used. We kept 24 the same. So that means we're going to look at 7 6/10. We turned it into 8. Our number increased. We used a number bigger than 7 6/10. That means our estimation will be higher. Your estimation is higher than the actual answer. All right, I'm going to grab my calculator real quick for sake of time. 7.6 times 24 is actually 7.6 times 24 is actually 182 miles, or I'm sorry, 182 and 4/10 miles. Our estimation was higher by almost 10 miles. So that's right, our estimation was higher because we took 7 6/10 and pushed it up to 8. And since we pushed it up, our estimation is higher. It goes up as well. Let's look at another one. Last one. Oh, a new record was set later by Ted McDonald. He must like the skateboard too. He traveled about 10 1/10 miles per hour. Whoa, that's fast. He did that for 24 hours. About how much farther did Ted McDonald travel? About how much farther did he travel? Well, he traveled 10 1/10 miles per hour for 24 hours. How far did he go? Before we can figure out how much farther, we have to figure out how far Ted went. So let's see, Teddy, he went 10 1/10 miles in 1 hour. How many did he travel in 24 hours? So once again, we need to multiply. Wait, it says about. It keeps saying about. So that means I can estimate. So 10 1/10. That one, that's going to turn into just a 10. And then remember, we're just leaving that 24 the same. And, oh, this is easy. If I ignore the 0, what's 24 times 1? 24. And then I got to put my 0 back in, so it's actually 240. So Ted traveled about 240 miles in 24 hours. Let's go back. What was his name? James. We said James did approximately 192. So James, let's make a note. James, almost 192 miles per hour, or in 24 hours. And then here we got Teddy. Ted did 240 miles. That's a 2. All right. James did 192. And the question says about how much farther did Ted travel? Now, if we think about our vocabulary, how much farther, how much more, that means I need to subtract. So if I subtract 240 and minus 192, I need to do some regrouping. I get an 8, I get a 4, and I get a 0. So Ted traveled about 48 more miles in 24 hours. Oh boy, I'm running out of space on my tablet here. Let me extend it. In 20, oh, that's a 2. That's another 2. 24 hours. There's our final answer. About 48 more miles in 24 hours. Sorry, my writing got all messed up, so it took me a minute to figure out what the heck I was trying to say. All right, so here's the bottom line. When you are estimating, go ahead and just take the estimate to the very first digit. But what you want to remember is if you have a number like 64 3/10, and we're estimating, we want to round to the first digit you see. Now, this is going to stay as 6 because the 4 is less than 5. So it stays as 6. It doesn't go up. And then I have to put a 0 here until I get to the decimal. Once I get to the decimal, I can stop adding zeros. So let's look at another one. What if we have 932 and 56 hundredths? Well, that first digit is what I'm rounding to. It's a 9. And if I look at the 3 keeps it a 9. So I'm going to write my 9, and then I'm going to put zeros. How many zeros do I need to get to the decimal? 2, because there's a 3 and a 2, and then I get to the decimal. So 932 and 56 hundredths rounds to 900. So when you're doing your work, go ahead and round to that first digit. Don't forget to put zeros, though, until you get to the decimal. And then you can go ahead and multiply and find your estimation. All right, so your assignment is attached to this video or this assignment. Don't forget to push turn in so that I know when you're done and I can check your work and give you some feedback. And don't hesitate to email me or to message me if something isn't working correctly or if something is not making sense. All right, good luck.